All right, today's the last section of Unit 4, and we're going to be talking about the final quadrilateral trapezoids. And so let's go ahead and write down a definition of trapezoid. This would be a quadrilateral, with exactly one pair of parallel sides. So go ahead and draw one for yourself. Here's our parallel sides. Actually, let's use some straight edges so it looks a little bit better. Hang on. There we go. So the two sides that are parallel would be marked, and then the other two sides are not parallel. But notice it has four sides, so that makes it a quadrilateral. So notice that we've got quadrilaterals as this entire overarching circle, and then parallelograms are a type of quadrilateral. And notice that a trapezoid is not part of the parallelograms group because it doesn't have two pairs of parallel sides. So let's go do some of the all or some conversation. So all trapezoids are quadrilaterals, and some quadrilaterals are trapezoids. No parallelograms are trapezoids, and no trapezoids are parallelograms. So this stuff we've been applying for the last 2 weeks, all the stuff we've been doing on parallelograms, does not apply to trapezoids. So why don't the properties of parallelograms apply? Because trapezoids are not parallelograms. Let's label all of the different parts. So this side part is a leg. This other side part is a leg. Down here is one of the bases of a trapezoid, and up here is the second base. Inside we have the base angles. That's a base angle. That's a base angle. This top one is a base angle. And this one is a base angle. So all those are considered the base angles. So base, base, leg, leg, base angles. Median of a trapezoid is a line segment. I'm going to go highlight it if I can over here. There's the median. Let's also label it. It connects the midpoints of the legs. So see how they marked right here that this is equal to this because it's a midpoint, and this is equal to this. Notice those are not equal to each other on the right and the left. Oops. Okay, it's always parallel to both bases. That median is always parallel to both bases, and it's the average of the two lengths, the two base lengths. So the median is the average of the two base lengths. So the length of the median is equal to half of base 1 plus base 2. This is another way of saying the average of the two bases. So we're going to go use this little formula here to do a practice example. So if this trapezoid, TRAP is a trapezoid, and XY is its median, follow the steps to find the length of TP. So we're trying to find TP, this one down here. So we know that the length RA is given in the picture. So looking up here, do you see how RA is 22.6? And we know the formula is that the median, XY, is equal to half of the base plus the other base. So the length of RA was given in that, 22.6, and the median was also given, 45.36. So these came from up here. Check this out. So this guy right here was given as the median up at the top, and this guy right here was given as one of the base lengths. And we're trying to find the other base length here. So here we multiplied by 2 to both sides to get rid of the denominator. And then that gives us 90.72 is equal to 22.6 plus TP. And then we minus 22.6 from both sides. Take a second to do that on your calculator, and that gives us 68.12. How'd you do? So that's using that new little median formula in order to solve. Okay, now there is a specific type of trapezoid that we want to talk about. Make sure you realize that this is possible. Unlike the one that I drew in the first picture, there are trapezoids that have congruent legs. And this is called an isosceles trapezoid. So what I mean by that is that the two side legs are congruent. So that would be marked like this. This is equal to this. This is called an isosceles trapezoid. Here are the properties of these isosceles trapezoids. It means that the legs are congruent, just like we just marked in the picture, and that both pairs of base angles are also congruent. So going back to that picture, it means that this angle is equal to this angle, and this top angle is equal to the top angle. Both pairs of base angles are congruent. And the diagonals are also congruent. So kind of like a rectangle and a square, the diagonals are congruent. If DEFG is an isosceles trapezoid, label the missing angle measures. So we know that both base angles are the same. So do you see the 75 and the 75 and the 105 and the 105? So what we're used to in parallelograms is that opposite angles are equal. But in this case, the base angles are equal. So be careful with parallelograms and those rules we've been doing versus this trapezoid. Okay, let's go do this practice. If we're given that this isosceles trapezoid, this is an isosceles trapezoid, so we know that this side is congruent to this side. We know the base angles are equal, and we also know that the diagonals are congruent, right? That's all of our properties. They're telling us that BD is 17. And they're also telling us that AC is equal to 3x plus 8. Setting up your equation, the diagonals of a trapezoid are congruent. We know this now as the property. So BD is equal to 17. And we know that that 17 has to be equal to the other diagonal of 3x plus 8. So subtracting 8 from both sides gives us 9 equals 3x. Dividing by 3 to both sides gives us that x equals 3. So see how we used that the diagonals were congruent to solve? Now let's just talk about the converse. Remember how we had the if-then statements that we practiced back in section 3? And now we're going to be talking about converse statements, just like that section, but about trapezoids. So if a quadrilateral is a trapezoid, then it has exactly one pair. And so then we can say the converse. If the quadrilateral has exactly one pair, then it is a trapezoid. They didn't give us that much space here, did they? Squeeze it in. If a trapezoid is isosceles, then it has congruent legs. If a trapezoid has congruent legs, then it is an isosceles trapezoid. And then let's go look now at our hierarchy of quadrilaterals. So here we have just a straight up plain trapezoid. Now stemming out from that, sorry, this isn't even a trapezoid, this is a quadrilateral. Why was this one not a trapezoid? Notice there are no parallel sides. So now, of all these quadrilaterals, we've studied parallelograms and trapezoids. Notice that this has one pair of parallel sides, and this one has two pair of parallel sides. That's the difference now. Notice underneath the parallelogram, we studied rectangles, we studied rhombi, and the most specific was our square. Based on this hierarchy, I can see that a square is a rectangle, a square is a rhombus, a square is a parallelogram, and a square is a quadrilateral. A square fits all the qualities, all the properties of all of the ones above it. And then there's trapezoid out off to its side on its own. Okay, we've seen all the quadrilaterals now. How are you doing? Let's go do the checkup.